When one number increases in value, this change can be represented as a number, a fractional increase, or a percent increase. In this video, we'll look at examples of numerical increases in value and see how this corresponds to a percent increase. Let's look at an example. From one year to the next, the number of students at a school increased from 525 to 612. What percent increase does this represent? Let's represent this change from 525 to 612 visually. This green bar represents 612. This smaller section represents 525. The section between 525 and 612 represents the increase, and we want to calculate the percent increase. How do we calculate it? Here is the formula for calculating percent change. The graphic and formula show that we are finding the fractional amount the red area represents. That fraction is then multiplied by 100%. In the numerator, calculate 612 minus 525 and divide that difference by the original amount, 525. This simplifies to this fraction, multiplied by 100%. In decimal form, the approximate value is 16.57%. This is the percent increase. Let's look at another example. A coin collection increased in value from $750.25 to $1,050.25. What was the percent increase in the value of the coin collection? The graphic and the percent formula show us that we are calculating the fractional increase, this red area, and multiplying by 100%. So in the numerator, we subtract the original value from the new value to find the incremental change. We divide it by the original amount to find the fractional change. We simplify the fraction to 300 over 750.25. We get an approximate value of 39.99%. This is the percent increase. Let's look at a final example. A cube's side lengths are increased from 4 to 5.25. What is the percent increase of the surface area and volume? In this example, we're looking at the percent increase along two dimensions, the surface area and volume of the cube. Here are formulas for finding the surface area and volume of a cube of length s. Notice that each formula is nonlinear, so we would expect the percent change to also be nonlinear. Let's start with the surface area first. The surface area of the original cube is 96, while the surface area of the larger cube is 165.375. Let's calculate the percent change. We find the incremental change in the surface area and divide it by the original surface area. The fraction simplifies to this, and we get an approximate percent increase of 72.27%. So as you can see, a small increase in the side length of the cube had a dramatic impact on the surface area. Now let's look at the volume. The original volume is 64, and the new volume is 144.703125. Let's calculate the percent increase. The fractional change in the volume is shown here, and that fraction simplifies to this. The result is approximately 126.1%. And once again, a small change in the length of the side of the cube results in a dramatic increase in volume. In fact, the volume is more than double the original volume. This graphic summarizes the percent increase in the side length, the surface area, and volume. Since length is a linear measure, it shows the least percent growth. Surface area, which is nonlinear, a square measure, shows the next highest growth. Volume, which is a cubic measure, shows the greatest percent increase.